Okay, so till now we have studied the density, velocity, turbulence, and the temperature, the three important attributes of the fluid container. Now we would like to go ahead with the fuel, which is also one of the very important attribute, and you're going to find that how important it is once you decided to go ahead with the reactions like fire and explosions. So we would like to begin with a term called as a fuel. So if you are thinking about the fuel, that it's going to be some liquid kind of the stuff which you're going to visualize inside the fluids, well, that's not the case. Here the fuel is going to interpret as the kind of a medium which will going to get mixed up with the density and will going to increase the heat. So technically it's favoring the temperature. Alright, let's go ahead with the definition and we're going to understand its meaning very properly. Fuel acts as an accelerator and helps in achieving a reaction with a more faster rate. That's a true fact. Think about the situation where you have the piece of the wood, and I'm also giving you a condition where the wood is sealed with some, you could say, by the impact of the external weathering, or you can say such a wear and tear. So the wood is, a little bit wet. You would be given with a lighter or with some small source of the temperature. You will be taking a lot of time to burn that wood, and at the end of the day it won't going to burn until unless you didn't spill the fuel upon it. So the fuel will going to act as an accelerator. It simply means that it will going to increase the rate of the reactions. So here I have mentioned that fuel combines itself with density, and once exposed to the temperature it will add more heat to the final reactions. Now the important thing is that fuel is a term which is very sensitive, highly flammable, and once it's exposed to the temperature it will just start burning it out. Alright, it's useful in having spontaneous fire and explosions. Okay, so here technically the thing is that, guys, fuel is getting entered inside the fluid containers through the ammeter. Alright, so it isn't like that we are throwing some liquid stuff, or we do have some solid pieces of the fuel which you can visualize. No, we are just modifying the properties of the voxels, and due to which the rate of reaction is being getting increased. So the ultimate thing is that your visualization should be with respect to the incandescence map which we have provided or plugged in inside the temperature field. So it means that if you are introducing the fuel to the state of the reactions, you're going to notice that the color values which are begin with the 0, that means that the color with the identity of the 0 will going to have maximum heat or maximum temperatures. So if you add fuel to your existing fluid simulations, you're going to observe that in the bottom sections you'll find more impact of those colors once the fuel is introduced. You're going to get the more practical idea once we start taking the discussion inside the practical ways in the Maya dynamics. Once I'll going to show you the process of creating the entire explosion. So we have the dedicated module for the fuel in which I'm going to show you the process of creating the explosions, and that will be totally based upon the fuel. So just don't worry about that, but just think of the from the theoretical point of view, that fuel is just a kind of an accelerator which is initiating the reactions. All right, now let's just quickly dive into the further attributes of the fluid. So we have the fuel scale and the reaction speed. Now the first term is being universal with all the attributes from the density, turbulence, velocity, as well as the temperature, as well as the fuel. So the fuel scale being the universal multiplier for all the attributes underneath. We have the reaction speed. Now very important thing, the reaction speed here will going to decide how fast the reaction will going to take place. Well, this situation is also depends upon further two attributes, which are the, no doubt, air to fuel ratio as well as the ignition temperatures. So I would like to go to the reaction speed. It means that if you have the reaction speed to the 0.1, so that means your entire fuel will going to get burned away in 30 frames. If you have the reaction speed set to the 1, it means your whole fuel will going to get burnt maybe within 5 frames or 10 frames. So the reaction speed will going to increase the rate of burning of the fuel, but it also depends upon few things. One is the air to fuel ratio. Air to fuel ratio decides that the percentage of the fuel which is mixed up in the air, and it goes with the density. So the thing is that if you are creating an explosion, so you may notice that once it reaches to a certain level above the surface, there is a fire blowing in the upward regions of the explosion also. So this is just because of the air to fuel ratio. And to create an explosion kind of effect, the magnitude should be around 12 to 16 to get the most realistic behavior of the explosions. Alright. Next we have the ignition temperature. Ignition temperature could be replaced with a word called as the minimum temperature. So the minimum temperature under which the fuel would start burning. It also depends upon another attribute that is called as the max temperature. So this particular fuel will going to be a little tricky, but its results are crystal clear once we get started into the practical side of the Maya fluids. So I was talking about the ignition temperature, which could be replaced with the minimum temperature. Now the minimum temperature means that once this value is reached, fuel will start getting burned with respect to the reaction speed. And for the max temperature, this is the attribute in which once this state is reached, the whole fuel will going to get burned away. So the fuel will going to burn between two values, that is the ignition as well as the max temperature. Once the fuel is completely burned, obviously the heat will going to get released. That's the universal thing. And once the heat will going to release, it has to show its output. It will going to show you with two ways. One is a light release, another is the color. Okay, well, I don't prefer the light color because I think so it's going to be based upon the scalar value. We don't have the 3-channel workflow in that case, but no doubt, since being an important attribute of the fluid, we need to understand everything. So obviously when heat will going to get released, it will going to show you itself with respect to the incandescence map, where it will going to pick the most hottest zone of the colors. Obviously those colors will be at 0 positions of the color entry list inside the RAM. Okay, so with that, I hope so you have understood the concept of the fuel, and with that also we are done with the module 1. So I would like to summarize this module. We begin with the concept of the fluids, and we understand the term called as the voxels. Further ahead, we go inside the fluid containers by taking care of the different types of the fluid emitters that we have available inside the Autodesk Maya. And then we studied deeply inside the container details. That was having a lot of definition stuff inside it, but just don't worry about that. I'll give you some cool tip on that. We studied the fluid container details with respect to the density, velocity, turbulence, temperature, and the fuel. Alright. So with that, we are done with the module 1. But before you jump ahead to the other modules, I would like to give you one advice that first of all, just don't afraid of the big definitions that we have in the density, velocity, temperature, and the fuel clips. You don't need to require to learn the definitions. You just require to go through with them, because the good thing regarding the course is that in this particular module we have the density clip, alright, that you have already understood. For our upcoming modules, we are also going to have the density modules, which is based upon this density clip. So it simply means that if you have understood the concept theoretically of the density clip, you will going to utilize the entire module very properly. Alright, so just don't need to learn the definitions, just go through with them, just read them out, just understand the concept, and then you are good to go and follow the other modules. Alright, so see you in the next modules, where we would like to begin with the creation process of the fluid emitters.